Good morning everyone and welcome to Women into Wind. Hopefully this webinar will help you step into the sector, gain a bit of knowledge about floating offshore wind and give you a bit of an overview of what a career in offshore wind might look like. Here's a brief agenda for today. So we're going to start with a little introduction into offshore wind from me, followed by our wonderful guest speakers, Caitlin Gold from Tech Women, Michelle Hitches from Offshore Renewable Energy Catapult, and Emily Summers from the developer Simply Blue. We're going to leave all questions to the end and we're going to have a Q&A session with the panel. So this webinar is sponsored by Celtic Sea Power. So we are a subsidiary of Cornwall Council and we specialise in industrial strategy. We have a base in Wales, in Pembroke and in Hale, Cornwall. There are 18 of us on the team so far, all from a range of different backgrounds. So I'm from social science and we have a load of engineers and we've got some naval architects and people from the forces as well. We aim to facilitate the development of floating offshore wind in the Celtic Sea and to maximise the benefit for Cornwall and the wider region, so get a pipeline of people ready to work there. This webinar is also funded by the Future is Green project, which is a Shared Prosperity Fund funded project. They aim to develop green skills in Cornwall, and their main aims are to retrain high carbon sectors and to drive the transition to a green economy. So we work with a range of training providers from across Cornwall, including Cornwall College Group, Truro and Penwith College, and the various universities around the region, among many others. So we're going to start with just what is wind power. I'm sure many of you already know how it works, but the basics of the technology remain the same, whether the technology is onshore, offshore, or floating. So the blades turn, which turns a rotor inside of the hub, and then this turns a generator, which converts the kinetic energy into electricity, which is then transported onshore or to a substation through cables into the national grid. So we have actually been using the power of wind since the 1100s, where we used windmills to mill the crops. So the technology is not completely new. The first windmill to generate electricity was actually built in Glasgow in 1887 by James Blythe. But the thing that really kick-started the development of commercial scale wind power was the 1970s energy crisis in the US. And this was because they wanted to reduce their dependency on imports and increase their domestic production. This has really been compounded with climate legislation and a popular drive to decarbonise. The Southwest has also been pretty instrumental in the development of the UK's wind power. So our first onshore wind farm was built in North Cornwall, and that was the Delabole wind farm in 1991. And the first offshore wind farm was built in 2003 off the coast of North Wales, and that's the Blythe offshore wind farm. And the reason that the UK is so good at offshore wind and wind power in general is because we have quite windy coastlines and quite shallow seabeds. Offshore wind has been a really big part of the government's decarbonisation agenda. So as we all know, we are trying to get to net zero by 2050 as a country, and wind power actually accounts for over a third of our renewable generation, and the majority of that is offshore wind power. But alongside the decarbonisation agenda, offshore wind also supports the development out of our economy with a push towards a green industrial revolution and more of an emphasis on green jobs and highly skilled trades. This has been continued into the new government with the formulation of GB Energy, who have championed green skills and green energy and are investing in new technology, as well as upscaling and rolling out more mature tech like wind power and solar. Alongside this, they've also pledged to create 650,000 skilled jobs across the country, and 61,000 of these are going to be in the Southwest alone in renewables like wind, marine and nuclear. So the world's first wind farm was actually built off the coast of Denmark, and that was Vindeby, which you can see here in this infographic from Ørsted. So that was back in 1991, and they had around 11 turbines, and the whole farm produced 5 megawatts. The Danes have generally been at the forefront of offshore wind because they have quite centralised populations and they have quite shallow seabeds, so they've got a real jump start on offshore wind. And their energy system is more set up for intermittent energy sources, whereas the national grid is more centred around ready-to-burn fossil fuels and a centralised energy generation. And that's why you might have seen in the news that we've got quite long wait times for new renewables projects to be connected up. And you might have seen the new advert with the big plug for the Great Grid Upgrade. And that's to make sure that we can connect up more renewables projects. So after the first wind farm, there was quite slow growth for the following decade, but eventually the technology became less risky and the turbines increased in capacity and got lower in costs. But we've seen a really dramatic increase in the size of wind farms. So as you can see, Vindeby over here was less than a kilometre and only had 11 wind turbines, whereas over here in 2020 we have the Hornsea 1 project, which had 165 turbines and was 407 kilometres squared. So it's a really huge development. Hornsea 2 was similarly big, and that's 462 kilometres squared and was 170. Oh, that one was 175 and Hornsea 1 was 174, excuse me. So as we can see, the wind farms themselves are getting really, really big now. But it's not only the wind farms that are getting big, it's also the turbines themselves. So this infographic will show you just the development of turbines compared to national landmarks. And as you can see, between 2013 and 2021, they get really, really big. So this is just because larger turbines generate more electricity and tend to be a bit more efficient, basically. And so if we turn back to Vindeby over here, so that whole wind farm generated 5 megawatts. Well, now we are seeing turbines that are actually even bigger than the ones shown in this infographic, as tall as the Shard, and the biggest in the world is in China, and that is 16 megawatts. So it's 3 times the entire Vindeby farm outputs just from one turbine. So as we can see, not only have the size of the farms got bigger, but also the turbines themselves have got really big too. So currently our global capacity at the end of 2023 was 68 gigawatts, and according to RWE, they estimate we have around 1,360 gigawatts of offshore wind in development currently. So this is obviously going to have huge implications for the workforce, with over 100,000 people predicted to work in offshore wind in the UK alone. And we've seen really big investment into wind recently. So the allocation round 5 was pretty disastrous and no offshore wind developers actually bid in. But in allocation round 6, which happened quite recently, we saw 300 million put into offshore wind and 165 million put into emerging technologies like floating wind, which have enabled us to install turbines even deeper. So if you can see on this map, the brown and the red are the ones that are currently in construction or in operation, and you can see that they're mainly in the light blue areas, which shows the shallower waters. What we're going to start seeing now is an increase in development in the deeper waters, which are indicated by the slightly darker shade. And that's because of the development of floating wind. We're able to deploy even deeper. And so we should see development in the Irish and Celtic Sea, which is going to be a bit different to the volume of projects that we've seen on the east coast of the UK. So what actually is floating wind? Well, as I said before, the technology is really similar in the turbines. So same technology, but they're just built on floating platforms. So the platforms tend to be built on steel or concrete and then anchored to the seabed with mooring lines that you might see on large ships. So in this infographic, we can see 3 different types of platform. There are many different types, but these three are the monopile, the semi-submersible platform, and then the tension leg, and you can see they're all anchored to the ground in different ways. So this means that we can deploy in depths greater than 50 meters, which before was kind of out of the question. And this is great because out to sea, the winds tend to be more consistent, which means that the turbine should have a greater yield. So this is being tested on a commercial scale in Scotland, and it's a really globally developing technology. So we have 4 wind farms in the world. We have 2 in Scotland, we have 1 in Portugal, and we have 1 off the coast of Norway. And these turbines will basically be assembled at ports and then towed out to the wind farm sites, and then subsea cables will transfer the power back to shore. So what does this mean for Cornwall? Well, in the Celtic Sea currently, we have 3 1.5 gigawatt project development areas which are currently being leased by the Crown Estate. So they aim to deliver up to 4.5 gigawatts of power in total. So each site is going to have around 100 turbines, which are going to be 15 megawatt turbines, so on the larger scale. But as well as the excitement around the technology, it's also pretty exciting in terms of social development in the region. So the Crown Estate has written into their new leasing bids that developers need to have 3.5% of their workers need to be apprentices, 10% of their workers need to be or have recently been not in education, employment or training, and they also have to provide a skills development plan, an environmental plan and community engagement and support, as well as voluntary work plans. So we should see a real social benefit alongside the economic benefit from this investment in the region. So there's going to be a real drive to get people into the industries today so we can harness the benefits for tomorrow. So this is a recently released map from the Crown Estate, which basically shows their areas of search, so where they're going to look to put new turbines. And I know it looks like a lot, but it's only going to be 12% of the green area down here, and then 15% of the blue area up here in the northeast. And this is really great because it shows that they're going to put a lot more investment into the southwest area and the Celtic Sea. So a few years ago, we produced a missing middle report, which basically had workforce predictions for Cornwall. And we predicted in an ambitious scenario that 4,300 jobs were going to be created by flow, and that's in Cornwall alone. And this, released by the Crown Estate, kind of shows that that's more likely to happen now, because as well as them looking around Cornwall, they're also extending the transmission network into Cornwall so that projects can be connected up. So we should see real investment in the region. But what does a job in floating wind really look like? Well, I can imagine that most of you probably think of this. Hard hats, high vis, up a turbine or on a boat. Well, this is only going to be a really small amount of the workforce. Most of the jobs in floating offshore wind will be across other areas in the supply chain. So the areas we're going to see affected the most are anchors and moorings, cables, concrete, and operation and maintenance. And within these different sectors, there'll be lots of jobs going down, basically. So this is a timeline of just the pre-consenting phase for floating wind development. So as you can see, it's pretty long. It's about 2 years long, and that's before they even have consent to bid or any leases are given. So it's a really long timescale, and it requires quite a lot of administrative work. So this will mainly be environmental impact assessment, stakeholder engagement, licensing, and securing grid connections. And I'm sure that a lot of you can probably do that already. It's a real development of soft skills and digital skills, which are really important in the economy, as well as the technical skills that might be needed further down the line in the construction phases. So as you can see, there's just a couple of jobs that might emerge in this industrial ecosystem that's needed to deliver flow. So we've got marine engineering, construction and electrical trades, which might come later down the line, but a lot of it is going to be equipment hire, environmental work, and then business support, which is really, really important across the lifetime of the project. So this is just a little infographic that shows potential jobs in Flow, and if you have a look on here, I'm sure that you can pick out a few jobs that you either have the transferable skills to work in or maybe even work in already. So ones that are important prior to the construction would be the legal services, the environmental surveys, stakeholder engagement, marketing and business support, as well as planning. So most of these are before construction starts. And the kind of key ones at the moment are the stakeholder engagement and marketing, because they develop the image of the wind turbine and wind farms, and then legal services, site management and environmental services are more to do with the planning and work for the developers. So just take a little look at that, and I'm sure you can pick out many jobs that you could already do. You already have the skills to work in offshore wind, and you probably already do without knowing it. It's just about pivoting into a new role. So, I'm a perfect example. I don't have a background in offshore winds at all. I'm actually a graduate of politics and geography, and I have a background in customer service and electric vehicles. So I ended up working in offshore wind just because I had a slight interest in the energy sector, and I wanted to use my politics and geography to pivot into something that would have more of a focus on the energy industry. And then I'm on the workforce team, so we're trying to get a pipeline of individuals into the sector and accumulate social value for the region. So that works really well with my skill set, but it's completely different to what I did in electric vehicles and customer service roles. So don't be afraid to kind of pivot into something new, because I'm sure you have the transferable skills to work in it. So I'll never work up a turbine, I can say with some certainty, and that's mainly because I don't think I could pull off a hard hat, but I do have a job in offshore wind. So my top tips for kind of getting into the sector are keep up to date on energy news, because employers find that really, really valuable, and even for your own knowledge and confidence, it's great to be up to date on everything. Build your skills. There are so many free programs available to you for you to kind of do a few hours a week just to build your skills up and fill a gap that you might have, even if it's just building your own confidence in an area that you already know. So I have produced a massive list of a bunch of online courses and some in person at different colleges of free courses in Cornwall and the Southwest that relate to Flow, which I will send out to you guys after this call. And that basically will hopefully give you a few avenues to go down if you want to build some skills. And my final tip is reach out to companies. LinkedIn is such a brilliant tool, and I'm not sponsored by them, but they are fabulous. So keep on LinkedIn, follow companies you're interested in, reach out to people, go to different events, and sometimes a well-timed email will do more than you know. I got my role at Celtic Sea because I sent them an email and I just reached out. They might not be advertising that they're hiring or that they have positions open for work experience and that kind of thing, but it's if you send them an email and you show the interest, then sometimes that's all that's needed. So I'm going to move on now to my fabulous guest speakers, and you can check that out in part 2 of this recording.